Welcome everybody. We got a beautiful question. Tan 10 times tan 20 degree times tan 30 etc. up to tan 80 times sigma n is equal to 1 to infinity tan inverse of 2 over n squared. We have to evaluate this quantity. That is the requirement. So foremost what I wish to do is I will consider the sigma part. N is equal to 1 to infinity tan inverse of 2 over n squared. Now this 2 over n squared, I would like to rewrite it as 2 over n squared. I add a negative 1 and I counter it with a positive 1. This is acceptable. So this can be rewritten as 2 over. Now this is of the form n squared negative 1 squared positive 1, which is of the form a squared negative b squared, which can be rewritten as a negative b times a positive b. So I'm going to rewrite this as 2 over n negative 1 multiplied with n positive 1 positive 1. Okay, now this 2 I can rewrite the value 2 as n positive 1. Then I need to get rid of that n, so I would place this value as negative n and a positive 1. So 1 added with 1 will give me 2, negative n added with n will get neutralized. Further, I will rewrite this as n positive 1 as one group and then take the negative sign out and rewrite it as n negative 1 with a negative sign being present outside. So we now have a new expression for sigma tan inverse of 2 over n squared. Of course, n is running from 1 to infinity, so this is rewritten as sigma 1 to infinity tan inverse of, in place of 2 we have n positive 1 negative n negative 1 divided by, and I would like to rewrite this as 1 positive n positive 1 multiplied with n negative 1. Okay, fair enough. Now this is a very popular result, a formula, which is rewritten as tan inverse of a negative tan inverse of b is equal to tan inverse of a negative b divided by 1 positive ab. So in place of a, if I were to rewrite it as n positive 1, in place of b, if I were to rewrite it as n negative 1, this is going to be tan inverse of n positive 1 negative of n negative 1 divided by 1 positive n positive 1 multiplied with n negative 1. Okay, so in place of this I can substitute this. So take this and place it over here. Okay, it goes over here. So this is equal to 1 to infinity tan inverse of n positive 1 negative tan inverse of n negative 1. Now this is a all important step that is very vital. Now what I wish to do is I would like to rewrite this as sigma 1 to sum x, okay, tan inverse of, say, because n is actually running, right, n is equal to 1 to x, so this is going to be my n positive 1 negative of tan inverse of n negative 1. Okay, now over here it was initially n from 1 to infinity. Over here I'm introducing a variable x, n is equal to 1 to x, such that x is tending to infinity. Okay, now further I would like to rewrite this quantity. Okay, you see that this is actually having n positive 1, so I'm going to rewrite this as, because when n is equal to 1 you're getting 2, so I'm going to use tan inverse of some k. When n is equal to 1, our starting value is 2 here, so k will be running from 2 to, and it will go all the way to n positive 1, right? So this is going to be x positive 1 followed by tan inverse of, now we need to use another sigma. So this is going to be n is equal to 1, we have 0, tan inverse of 0. So the starting value will be k is equal to 0 to all the way to n minus 1. So it's going to be x minus 1 to tan inverse of k. So this is a very important step. Okay, of course x is hitting or tending towards infinity for all x tending towards infinity. So instead of saying all x, I will just say x tending to infinity because that is more confusing. So we can just retain it as x tending to infinity. So now the question is, see, you can just watch here, 2 to x positive 1, but this starts from 0 to x negative 1. So what happens here, my k is equal to 0 is paired, k is equal to 1 is paired. So right over here I have k is equal to 0 and k is equal to 1. So in this case tan inverse of 0 will be occurring, followed by tan inverse of 1. Those two things are spared. The rest of them will get neutralized by the quantities from here, because this quantity starts from 2. So from 2 onwards all the way to x minus 1, all of them will be neutralized. But x and x minus 1, or I would say x and x positive 1 will be retained. So this is going to be equal to tan inverse of x followed by tan inverse of x positive 1. So these are the 4 terms that would be left, okay, when we perform the calculations. When we sum this, we expand the series and sum it up. Now I'm going to tend x to infinity. Okay, so that was the next step. Over here, so what have you got? I would like to rewrite. So this is going to be equal to tan inverse of x followed by tan inverse of x positive 1, and then negative tan inverse of 0, then tan inverse of 1. Now tan inverse of 0, this goes off. So we are left with tan inverse of x and then tan inverse of x positive 1 followed by negative tan inverse of 1. Now as x is moving towards infinity, okay, tan inverse of x will tend to pi over 2, right, and tan inverse of x positive 1 will also tend to pi over 2. Of course tan inverse of 1, this is going to be giving me pi over 4. So we have a value of pi over 2 plus pi over 2 negative pi over 4. So this is going to give me 2 pi, right, followed by negative pi over 4, which is nothing but pi negative pi over 4. We take the LCM as 4. This is 4 pi negative pi, which is nothing but 3 pi over 4. So this is for the sigma quantity. So we just got this value, but we did not get this value, so we have to evaluate this value. So now I am consider tan 10 multiplied with tan 20 times tan 30 etc. tan 80. I'm going to rewrite this as sine 10 times cos 10 times sine 20 by cos 20 times sine 30 by cos 30 all the way to sine 80 divided by cos 80. Now I have a formula, sine theta is equal to cos of this is going to be 90 minus theta. Okay, so sine 10 is going to be cos of 90 minus 10. That is going to give me cos 80, and sine 20 is going to be cos of 90 minus 20. That is going to give me cos 70. So what I have got here, if I were to travel along this direction, the first value is going to be cos 80 multiplied with the second value is going to be cos 70, cos 60 all the way up to cos 10 divided by, I have a cos 10 times cos 20 multiplied with cos 30 all the way to cos 80, right? So cos 80, cos 80, cos 10, cos 10. So all of these things will get cancelled, giving me 1. Okay, so now what have I got? This quantity, I hope you're watching here. From this quantity I got 1. From this quantity I got 3 pi over 4. So the answer is 3 pi over 4. Okay, so that's the value for this question. You see here, and this, I hope you're watching this. Okay, this multiplied with this gives me 3 pi over 4. That's the solution for this question. Please like, share and subscribe. Thank you.